Resolution. Optical instruments are designed based on the laws of geometric optics. So, if we place a point source in front of an instrument at some distance, then the image of the point source produced by the instrument must be a geometric point. However, in reality, the light from the point undergoes diffraction and produces a bright circular patch of light surrounded by alternate dark and bright fringes. Suppose we are observing a nearby star with the help of a telescope. Here, light waves coming from these stars pass through the lens, making an angle alpha at the lens. The rays undergo diffraction and produce image on the screen. Since the distance between the stars is large, angle alpha will be large and diffraction pattern do not touch each other. Hence, the image of the stars can be seen as separate images. But if the two stars are very close to each other, the angle alpha will also be very small. The diffraction pattern of both the stars will be so close that they overlap each other. Due to this, both the stars cannot be seen as separate and we see only one star even though there are two stars. Now, if we replace this telescope with a more powerful one, the images would appear separate. The ability to view closely spaced objects separately vary from one instrument to the other. In fact, human eye can see two-point objects separately only if the angle subtended by them at the eye is greater than 1/60th of a degree or 1 minute. Based on this, resolving power of an optical instrument is defined as the ability to produce two distinctly separate images of two closely lying point objects. Rayleigh's criterion of limiting resolution. When two-point objects are seen with naked eye or with the help of an optical instrument, whether the two objects are seen as two separate objects or not depends on the separation between the centers of the bright disk of the images of the objects. The two objects may be just resolved, well resolved, or unresolved. According to Rayleigh's criterion, first criteria, two-point objects are said to be just resolved if the central maxima of one object coincides with the first minima of the other object. In this condition, the distance between the central maxima of these objects y will be equal to the distance between the central maxima and its first minima x. Therefore, if y is equal to x, the points are said to be just resolved. Second criteria, if two-point objects will be well resolved if the distance between the central maxima of the two objects is greater than the distance between the central maxima of one object and its first minima. That is, if y is greater than x, the objects are said to be well resolved. Now, third criteria. The two-point objects will be unresolved if the distance between the central maxima is less than the distance between the central maxima of one object and its first minima. Therefore, if y is less than x, the objects are said to be unresolved.